Good afternoon. My name is Stephanie Clark. I'm a senior psychology major here at CSU, and today I will be presenting my research of 5 years. My faculty mentor for this project is Dr. Diana Reiser. She's been instrumental in the success of this research, so thank you very much, Dr. Reiser. So the topic of today's presentation is the relation between childhood trauma, resilient characteristics, and brain activity. So to give a bit of a background on this research, childhood trauma has been shown to impair the function of the hypothalamic pituitary adrenal axis, which is the system in the brain that regulates stress. And what it can lead to is hypervigilance, hyperreactivity to stressors that's generalized across all stressors. So people aren't able to differentiate between things that are benign and things that are salient to their survival. And childhood trauma, unfortunately, has been associated with a number of health problems in adulthood, including anxiety, depression, obesity, cardiovascular disease, diabetes, and even suicide. So it has these really far-reaching ramifications on health, not just physical, but also mental. And so we were interested in looking at the relation between childhood trauma and brain activity, but we were most interested in seeing if there are any sort of techniques or emotion regulation strategies that people can use to protect against the effects of childhood trauma on brain activity in adulthood. So the way that researchers typically analyze brain activity is by extracting event-related potentials from raw EEG data. So what event-related potentials are their averages of brain activity across multiple electrode sites on the electrode cap and multiple trials of the experiment. So if I'm passively viewing images, then a researcher would take a time window of brain activity post-stimulus presentation and average that across multiple trials. And that gives you this nice waveform that's thought to be related to the event and to the cognitive processes associated with that event. So we looked at ERPs and we also looked at resilient characteristics, particularly constraint and reappraisal. Constraint is impulse control, avoidance of risk, and avoidance of unconventional behavior. And reappraisal is the ability to reevaluate stimuli in a more positive light. And both of these things have been related to brain activity by prior research. So in part one of this experiment, we invited participants to the research lab and we gave them a series of psychological surveys to measure their levels of childhood trauma and their resilient characteristics, so constraint and reappraisal. And then we invited them back to part two, where we put an electrode cap on their head, which this nice woman in the background is wearing. And we presented emotional and neutral images to them and recorded their brain activity as they passively viewed these images. And we presented 3 sets of images to each participant, so neutral, pleasant, and unpleasant, which you can see from the left to right here. And the pleasant and unpleasant were defined as the affective or emotional images. And what we did is we compared brain activity in response to these affective images to brain activity in response to neutral images. So what you see here are event-related potentials across all our participants. And what you can see is that the neutral images, shown by the blue line here, evoked a smaller brain response as compared to the pleasant and unpleasant images shown by the red and black lines here. And so what we did is we took the difference in amplitude between the neutral and the unpleasant and pleasant images to find difference waves, which is just a wave that shows the difference in amplitude between neutral and affective images. So we had 2 difference waves for pleasant images and unpleasant images across the early posterior negativity, or EPN, and the late positive potential, or LPP. The early posterior negativity is a type of event-related potential thought to reflect early visual attention, and it's recorded in a time window 175 to 275 milliseconds post-stimulus. And the late positive potential is thought to reflect more controlled emotion processing implicated in the frontal lobes and things like that, and it's recorded 300 to 600 milliseconds post-stimulus. And the reason that we looked at difference waves in particular is because difference waves are thought to reflect affective discrimination, or the ability to distinguish between neutral or benign stimuli and affective stimuli that might be important, might be salient to survival. And so difference waves with larger amplitudes are thought to reflect more robust affective discrimination. And we did find a significant correlation between higher levels of childhood trauma and smaller difference wave amplitudes, which means that people with a higher rate of childhood trauma tended to be worse at discriminating between neutral and affective stimuli. In addition, we found a significant correlation between childhood trauma and lower rates of constraint. So people with higher rates of childhood trauma tended to have less impulse control, were more prone to risk-taking, and engaging in unconventional behavior. And we also found that constraint significantly moderated the relation between childhood trauma and late affective discrimination between neutral and unpleasant images. So what that means is, as you can see by the graph here, people with higher incidences of childhood trauma, as measured by ACE scores, adverse childhood experience scores, but also had higher levels of constraint, as shown by the green line here, tended to have difference wave amplitudes in response to unpleasant images in particular that were more similar to people with lower rates of childhood trauma, which suggests that constraint is a protective factor against the effects of childhood trauma on brain activity, which was really, really cool to find. And in addition to testing for moderation of constraint on the relation between childhood trauma and brain activity, we also did this for reappraisal, but we did not find that reappraisal moderated that relation. Instead, we found that reappraisal predicted reduced late affective discrimination between neutral and unpleasant images. And we suspect that this is because reappraisal is the ability to downregulate your emotions in response to unpleasant stimuli. So perhaps it actually reduces your brain activity in response to unpleasant images, which in turn makes the difference wave smaller. So it seems to reduce affective discrimination when really it might just be generally calming you down in response to those images. So I think that these findings are actually really relevant to what we're going through right now with the pandemic. And if you think about the amount of children who are being deprived of novel environments, who are, experiencing social isolation due to this, it makes you wonder how that will affect their health in adulthood, and we might not know those ramifications for years to come. So if there are any takeaways from this presentation, it's that there are very actionable steps you can take and that you can teach your children that protect against the effects of childhood trauma on brain activity and health in adulthood. And those include things like constraint and reappraisal. So I hope that you've enjoyed this presentation. I hope that you've learned something, and I hope you have a wonderful rest of your tower day. Thank you very much.